All right, let's look at the gamma function. All right, gamma function is kind of a strange function, but surprisingly, this is comes in very handy when it comes to simplifying Laplace transform. All right, so here's the definition. Gamma of x is defined to be integral from 0 to infinity e to the negative t times t to the x minus t with respect to t. All right, so there are some properties that we want to look at, and the first property of gamma function is gamma of 1 is 1. All right, and also second property is gamma of x plus 1 is x times gamma of x. All right, and by combining number 1 and number 2, we can conclude that the gamma of n plus 1, where n is a natural number, then it's n factorial. All right, and the fourth property is gamma of 1/2 is equal to square root of pi. All right, so it might take another video to explain, the property number 4, but we can explain number 1 through number 3. All right, so let's actually just go ahead and compute gamma of 1. All right, so we have a gamma of 1 is by definition integral from 0 to infinity e to the negative t, and if you plug in 1 for x, so t to the 0 is 1, so you just get this guy right here. All right, so this is going to be, if you take the antiderivative, you get e to the negative t over negative 1, and then going from 0 to, I'm going to use b, then put the limit as b approaches infinity. All right, so this is going to be limit as b approaches infinity. Then we plug in b here, so it's going to be e to the negative b over negative 1. Actually, I should have just called it negative e to the negative b, right? Minus, so this is going to be plus, plug in 0. E to the 0 is 1, so we just put 1 here. All right, so you can see that the b is going to infinity. We know that this first term approaches 0, so therefore you get 1. All right, so we could verify the first condition here. All right, so let's look at the second property. So let's compute gamma of x plus 1. All right, so this is going to be integral by definition from 0 to infinity e to the negative t. All right, so this is going to be t to the x plus 1 minus 1, so this is going to be just the x dt. All right, so I'm going to use the integration by parts. So we're going to say I'm going to let let's see, I'm going to let u to be t to the x, and the dv to be e to the negative t dt. All right, so from here we know that du is going to be x times t to the x minus 1 dt. Right, here v is going to be negative e to the negative t. All right, so doing the integration by parts, uv, so it's going to be a negative t to the x e to the negative t, and then you're going from 0 to infinity, so I'm going to do b, and you have a limit as b approaches infinity. All right, minus, there's a negative sign, so plus integral from 0 to infinity. All right, so x is just a number, so I'll put it out here. So you have t to the x minus 1 dt, and b is e to the negative t. All right, then you notice that here we see something familiar. This is the definition of gamma of x there. All right, then here's the limit we need to compute. So this is going to be a limit as b approaches infinity. All right, plug in b. So you're going to get, let's see, so you have, how do I write it? So it's a negative, all right, b to the x over, I'm going to write e to the negative x as e to the b on the bottom. All right, and then plug in 0, it's going to be 0. So it's a minus 0. All right, then we have x times gamma of x. All right, but here, as b approaches infinity, b to the x over e to the b is going to approach 0, because you can see that if you take the derivative of this guy, and eventually you're going to get, say x is equal to, say, 2 or something like that. If you take the derivative twice, you get the constant value. So this limit is going to approach 0, because the exponential function never goes away. So by applying L'Hopital's rule probably multiple times, we know that this is going to go to 0. All right. So what's left is x gamma of x. All right. So that will verify the second property. All right. By combining the first property and the second property, we can verify the last one. So because the gamma of n plus 1, by second property, n times gamma of n, but the gamma of n would be n minus 1 gamma of n minus 1. But the gamma of n minus 1 would be n minus 2 times gamma of n minus 2. And then you just keep on doing that until it becomes 1. So you get n times n minus 1 times n minus 2 times and so on, 2 times 1 times gamma of 1. You just keep on doing that. But property number 1 said that gamma of 1 is equal to 1. So therefore, this is just exactly the same thing as n factorial. All right. So property number 4, we need a little bit more room to explain. So I'll explain that in a separate video. All right. So this is called a gamma function, and surprisingly, this comes in handy later. All right. That's it. I hope that this was clear.